Welcome to the Real Python Podcast. This is episode 226. What goes into building a spreadsheet application in Python that runs in the browser? How do you make it launch quickly? And where do you store the cells of data? This week on the show, we speak with Chris Laffra about his project PySheets and his book Communication for Engineers. As a software engineer, Chris has worked at IBM, Google, Uber, and several financial institutions. He speaks about developer productivity and communication skills as an engineer. We begin our conversation by digging into his background, building engineering teams, and improving communication. Chris's idea for PySheets is to have Excel inside Python, with everything running locally in your browser. He was inspired by the success of Jupyter Notebooks, but wanted to develop a tool more suited to a spreadsheet's nonlinear graph structure. PySheets is built to run locally in the user's browser, taking advantage of PyScript. We discuss finding the right solution for storing data in the browser and developing a graphical toolkit to create the UI. Chris also shares the novel method he found to get the interface up and running while the larger assets are loading. This episode is brought to you by Sentry. Fix application issues before they become downtime with Sentry error and performance monitoring for Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Chris, welcome to the show.
Hi, nice to meet you.
Yeah, it's really nice to speak to you. I featured one of your projects recently on the show, and I was very interested in learning a little more. We're going to talk about the different projects that you're working on, definitely dig into PySheets. And where I kind of wanted to start, if you're comfortable with it, is looking into your talks, and I kind of followed your visual timeline sort of resume. You spent a lot of your time in your career building and motivating teams of developers. And I think that's really fascinating to me. And what was that like?
Yeah. So my history is I grew up in the Netherlands. I'm a Dutch resident, but I lived almost half my commercial life and then my professional life in the US, mostly on the East Coast.
Okay.
So I have experience with both cultures, probably. I have a PhD in computer science, so I designed an object-oriented language, and it came out in 1992, which was about the same year that Python became popular, actually, when Guido moved to the US. And I moved to the US in the same year. And of course, everybody knows the Python language, and nobody knows my language. It also starts with a P, but the funny thing is that my language was actually ahead of its time. So it was a distributed language, an actor language, and it had a graph database built into the language already.
Interesting.
So all these things, like we tried to solve problems that weren't problems in 1992. They are problems right now. But
yeah.
So I think that's the excuse I have personally for Python being successful, was that I was much more pragmatic at the time. It was just solving a problem that people had, is like, how do you script a couple applications together? How do you get data from here to there? And the problems we were trying to solve were, probably too far out. So
ahead of your time.
Yeah, ahead of our time. But maybe I should revive the ideas from that language and come up with a new idea on top of Python, for instance, to do something similar, but maybe, I don't know.
Can you just briefly describe what you meant by distributed?
So in a language, the Python language and JavaScript, for instance, in the browser, they have a main thread. So this is the thread that starts when you bring up your program and it runs main. And at that moment, you can do only one thing at a time.
Right.
It is in one sequence.
The whole GIL of it all and such.
If you want to do things in parallel, you have to create multiple threads. And then you have to get access to the memory. And the memory is then the bottleneck. And this, you mentioned the GIL. So the GIL is basically the guard that will allow you to use the same shared memory from different threads that execute in parallel. But they don't really execute in parallel. They're always synchronized, right? So if you have a really distributed language, it means that all the threads are running independent of each other. They don't share memory.
Okay.
And the way that they share information is by message passing. So it's basically a big system of microservices that interact with each other. And in the 1990s, we called these actors, so actor languages. So objects had their own behavior. They could move around between different nodes on the network. And that was very popular, that kind of research topic when I did my PhD, was to investigate distributed programming. Later on, we got much more practical applications of these ideas in MapReduce, for instance, that came out of Google to basically break up your work in a couple different parts and then run this in parallel and get back the results.
Yeah.
So this MapReduce is a functional programming metaphor that became really popular then.
It's interesting that I feel like the language that you were developing would have really required kind of a university structure, in a sense that you'd have these multiple machines networked together, or at least some form of networking in the 90s. And of course, this is probably on the cusp of the internet coming along, and even multi-processing of individual computers or GPUs, all this stuff that's come after, where the distribution would make more sense to us today.
Yeah, I don't want to sound like an old person, but it's like usually people from my age, they complain about how easy people have these days, right? If you want to
right.
like design a new distributed language, you buy 10 Raspberry Pis and you put them in a little network and then you can experiment.
Yeah.
We couldn't do that in the 1990s. The framework, the mainframes that we had were about the computational strengths of a Raspberry Pi. So it's problems arise, and what I have seen is that the same problems come back all the time.
Yeah,
I had to do one assignment with other students. We had to build something together, and there were 4 of us, and one of the 4 never showed up. We did all the work, the 3 of us, and then finally it was presentation time. The guy showed up, and he wanted to do the presentation, and he did the presentation, and he got all the credits. Yeah, communication skills have always intrigued me, like how teams collaborate, how individual skills can be complemented in a team. And what makes a team successful? This is we still haven't figured this out.
Yeah.
After so many decades of having this. It's still an art. Software development is still an art. And AIs are not really helping. They are helping on the surface. They make us look really productive, but in the end, I'm not so sure if our industry will be more productive. Maybe we have long-term, a trauma from applications being built in the 2024 timeframe. 10 years from now, they're going to lament all these generative AI applications that were cranked out by these people. Nobody can support them.
Yeah.
So we'll see. This is we're very exciting time that we live in.
Yeah, you mentioned the communication part. I agree with you in a sense that a lot of the use cases or at least some of the use cases for AI are trying to, you hear people joke about it, take these 5 bullet points and turn it into an email, and then the person on the receiving end is take that email and turn it into 5 bullet points. And it's just is this truly communication at this point? I'm not a computer science graduate. I studied engineering and went off and did this whole music career thing, and kind of got back into stuff kind of late in life. And I love programming, and I think it's fascinating, and partly why I do the show and get to interview wonderful people and talk to them. But I have been in sales. I have been on multiple sides of these situations. And I feel like that's the one skill I have, is that I can try to break terms into the developer speak.
Yeah.
Talk to the project manager people, and I can talk to these other people across the strata. And that's hard because everybody's coming from a different point of view. That's something you've written about, I would guess, in some ways in the book that you did.
Yeah, this concept you mentioned is called empathy.
Yeah.
And that means that it's part of what's called emotional intelligence, and it comes at the end. So you need to develop some other skills before you can actually develop empathy. And one of the things is recognizing your own emotions. So if you just are very reactive, impulsive, and you just do what the system tells you to, right? And these days, we get so many interruptions and we get so many nudges from these AIs. Well, we used to call them machine learning models, now we call them AI, but the machine learning models that know exactly how to influence you. And they game you, and they basically push your buttons. So in that environment, it's very hard for us to actually be strong and say, like, I'm not going to do that. I'm going to make my own plans, and I'm grumpy today. And you're going to ask yourself, why am I grumpy?
Right.
And then you explain to yourself why you're grumpy, and you're basically doing self-analysis, but just mentioning the word that represents your emotion powers you to actually reason about it. And if you do this for a long time, then at some point you start recognizing these emotions in other people. Even if you're introverted, even if you're an engineer, even if you have ADHD, or if you're autistic, all our brains are different. And your brain might be wired differently. So for you, it's harder to understand other people. And I've seen that a lot with engineers. They want to solve problems, right? I love coding. I can sit down and I can code for 10 hours. This is awesome. And I just sit there and write code and go. And this is and this gives me energy.
Yeah.
Whereas if I go to a meeting, I sit there and I sit in a meeting and I'm still thinking about this problem. And then I come back to my code and I have to start over. And I'm sitting in this meeting like, oh man, this is going to be so horrible. And then you get out and this is not where you get energy. So how do you recognize this first? If you recognize it, you can weaponize these emotions and you can start to actually recognize them. You can become much more sort of productive, effective, impactful, and recognized. See, these are all nice words, but they mean actually that you get the most out of your capabilities. And we all want to be recognized. We all want to make impact. And for some people, impact means more money, more power, and more recognition. So that is also, you have to find that for yourself. And it's taken me 30 years to do that. So you mentioned a book.
What's the name of it?
So it's called Communication for Engineers. I'll hold up the book. You can't see this on the podcast, but if you look at the podcast materials, there will be a little video showing the book there. So the book that I wrote right when COVID started, and we were all sitting at home, and I started collecting all the things that I learned as a software engineer during my career. And I worked at places like IBM, Google, Uber, but also financial institutions like JP Morgan, Morgan Stanley, and Bank of America, which have dramatically different cultures.
Yeah.
But in the end, we're trying to build the same thing. Right?
Yeah.
We're trying to build highly scalable systems that take a lot of data, do something with it, and produce more information. And whether you do that at an investment bank trying to make money, or you do that at Google trying to get better search results. In the end, it's very similar, these problems. And this, we can call it data science or data engineering or data lake or whatever names we give it to it. It's not so different.
Yeah.
But what you have is different cultures. And especially at financial institutions, there is... I don't want to paint my previous employers too much, but this is you should never do that in your career. Say negative things about your previous employers.
Yeah.
But the industry as a whole is structured differently than technology. So in finance, you get short-term benefit. Like you get a bonus over the last year. And the bonus is based on your contributions, based on what you did, how your entity did, and how your whole company did. At technology, the whole reward system is structured differently. You get a grant for 4 years, and you get a quarter each year, or you get, the first year you get. So you have some vesting structure. But when you start, ahead of time for the next 4 years what's going to happen.
Okay, yeah.
So at that moment, you don't worry so much more at money. You worry more about how can I change the world? How can I make wonderful software? And how can I collaborate with other people to do something awesome? Whereas at the financial institutions, you're much more interested in figuring out what other people are building so you can steal it and then look better to your management, whatever, right? So there's a lot of competition, and collaboration there is much more difficult.
Yeah, I bet.
So that's an interesting sort of side perspective. communication is different in different cultures. And of course, cultures are also, like geographical cultures are different.
Yeah.
Whether you're, I don't know, on the East Coast or the West Coast of the US, whether you're in the South or in Canada, so these are all, communication is a really complex topic, and trying to distill that all into one authoritative book is not so easy. But it was a nice, very interesting challenge. So
yeah,
and this is why I picked a niche. I said, like, let's aim for engineers. Like, as an engineer, how should you communicate better? And the way we write software, right, you have different modules. So you start to break up your code into different modules. You have small functions and whatever.
Yeah.
And I wrote the book the same way. I've done this in an earlier experiment with John Arthorne when we wrote the frequently asked questions on Eclipse. And we always joked that John wrote all the questions and I wrote all the answers. It was the other way around. I wrote all the questions and John wrote all the answers. So John had the easy part, right? And that's always our joke. So asking the right questions is the most difficult thing if you're building structure, basically.
Yeah.
So once you have the structure, you can just fill it out. And this is what generative AIs do, right? So it's up to us to build the structure, and all the meaningless things are done by the AIs.
Yeah, what's interesting is, like, I feel like that's in so many of the different areas of my life. I agree with that. Like sales, like there's this huge part of qualifying people, asking these questions very specifically, like, well, what are you truly looking for? What are you going to do with it, and so forth? And this is the same stuff that applies to, building tools for other people and talking to other teams. And I always find that part the most interesting, of like just going around and, understanding like how somebody's going to use something or whatever. And it's pretty fascinating. Or like in your case of the the banking culture of like, well, what are other people doing? How can we do that? Or what have you. So
yeah, that's an interesting metaphor. You mentioned figuring out what customers want and how to sculpt your project against it, and find out what the motivations are. And I first had that happening when I moved to IBM Raleigh in North Carolina. And that's a huge location, by the way. They had like 13,000 people at that time.
Wow.
It's smaller now, and I moved there around 2006 or 7. And they had a big lab there. And it had, like, you see it in the movies, in these interrogation rooms with a half mirror, right?
Yeah, sure.
And so what they did is they put people behind the mirror and they made them operate the software. And they had like 5-6 people like observing them and seeing, like, what are they doing? Like, how are they moving the mouse? How do they look? And so they very much an experimentation, A/B experiments driven approach to figuring out what is the best way to deliver your software. So that's a very positive experience that I had at IBM.
Yeah.
I also had a negative one. So then we moved back to the Netherlands after a while, and because we had 2 little boys that we wanted to raise here. And we looked at different locations. I found a lab in Amstelveen, and we started a location there. And IBM found out that we had too many offices in the world, and we had to scale down. So we had to move to the main office and whatever. And as part of that, I had to become an official IBM manager. And I had to do a test whether I could actually be an IBM manager. So by that year, I'd been developing software for many years. I actually ran a team of 12 people in Amsterdam. So I thought, like, yes, of course I can run a team. So this is, around 2000. So I was going there. I arrived at the test stage, and they said, like, there was, like, not just me, there were like 7 or 8 other people. And they said, like, so the first test we're going to do is you're the new salesperson. You come in and you're replacing Joe. And Joe was the salesperson of this, and he's gone, and you're the new one. And here's all the technical information about the thing he sells. They picked a topic that nobody knew about, of course. This was like CO2 reduction in chemical, something very technical.
Yeah.
And a big stack of paper. So you have an hour to study the materials, and then you're going to have your interview with, like, the new customer. So this is your preparation. So I studied this material, and it was a big stack. It was impossible to read in an hour. I read it in an hour, and I knew all the details. I could actually recite it. I could do a presentation. I could sell this stuff. I knew it. So I went into the room, and there were like 2 people sitting there. And I said, hello, I'm Chris. Where's Joe? This is the first reaction. Joe left the company. I'm the new salesperson. Oh, we don't want to talk to you. We want to talk to Joe. Yeah, but Joe isn't here anymore. And they were very aggressive, like agitated. And so at some point I said, like, yeah, I'm the new salesperson. I want to explain to you how our software works, our hardware works, how a solution works. After a while, okay, they allowed me to actually do a presentation. So I went to the whiteboard and then I drew up like all these complex things. And I thought I did really well. And then I turned around. This was like half an hour into this thing. And I look at the room, and this is a stage room, right? This is a fake room.
Right.
Yeah, so they're sitting behind a fake desk, and it's just like, and I look in the room, and in the corner there's like the golf set, and on the desk there's a picture of a female and two kids, and obviously his wife and two kids, and then on the wall there are pictures of New York and Paris and whatever. And I was like, okay, I missed all the hints. They wanted me to talk about golf, of course, and I should have asked him about his
discuss
kids.
His family and stuff. Yeah.
So the final, and then a few weeks later after that thing, I got a letter back from this testing station, and it said like, Chris is probably really good at developing software in small technical teams, but he will never become an IBM manager. So that was, for me, most people can get deterred by that, right? Like you can get, what's this?
Or they can use that as a lesson.
Company. I'm going to do it. Yeah. But I used it as a lesson. I said like, wow, that's interesting. Yeah. And this is how I should change myself. So I started reading books about this topic and tried to do this myself and interact with people.
Yeah.
And I've built up these skills, and I try to develop empathy against backgrounds. So at larger companies like Google, for instance, a team is usually consisting of a product manager, a project manager, engineering manager, a tech lead, and then 3 or 4 or 5 normal engineers.
Right.
Sometimes also a UX engineer, but they are often shared between different teams. So these individuals have completely different backgrounds, different ways of thinking about things, different words that they use, different clothes that they wear, iPhones versus Android. There are all these like very subtle differences that sets them apart. And when they have lunch, all the iPhone people have lunch together and all that, right? And so once your radar is open for that, you can see this happening. This is also how I actually got into Google, because I was interviewing. And I learned from that lesson in Amsterdam by the test what I did. So I interviewed with a guy, and I saw his watch, and he had the same watch that I had. It was a Pebble watch.
Oh, okay, yeah.
And it was one of the early ones where you could actually write software for it. So I saw his watch. I said, like, wow, you have a Pebble too. Did you write any code for it? And he said, yes, I did. Oh, me too. That's awesome, right?
There you go.
And before you know, we were talking about writing apps on Pebble.
Yeah.
And then 10 minutes before the end, he was, oh, shit, we still have to do the interview.
Yeah. You developed a friend. Yeah.
So this is a practical application of how you make friends and succeed in life is you pick up on these things.
Yeah.
And people send out all these signals. Like most engineers have laptops with stickers on them. Now, they do that because they love the technology. They want to be part of something. But you as an individual, you can pick up on that. You can see there, and you know these things, and you know the kind of technologies that they care about. Yeah. And then you hone in on that.
It's like the bumper stickers on people's cars as you drive around.
Yeah.
And you're like, they have a kid who's playing soccer.
Exactly.
And they have 2 dogs and,
So pick up on these things. Yes.
Yeah.
Look what kind of watch they're wearing. Look what kind of clothes they're wearing. Because people like people that are like them. That's always the case. And even if we want to be diverse, we want to be inclusive. And I actively am inclusive in a lot of things, but it's just unavoidable that this is how our brains are wired, as from the caveman history, is that we like people that are like us, because if they're not like us, they're probably from a competing town or country and they want to steal our stuff. So you're naturally defending yourself against people that are not like you.
Yeah.
This is one of the things that I learned, and this applies to technology as well. We wind back to the first word. One of the first words you used at the beginning was PySheets.
Yeah.
So I started writing PySheets about a year ago. Microsoft came out with a technology called Python in Excel.
Yep. I had a couple people on the show to discuss it. Yeah.
It's a brand name. Yeah. So Python in Excel means that rather than write the Excel programming language inside cells for expressions, it is a programming language. Like, it's not sold like that, of course, to business people,
Right.
but it's really almost Turing complete language. You can write expressions in it, but it's not as powerful as the whole data science ecosystem that is built around Python. So how can I do something similar to what you can do in Python in Excel is what Microsoft added with help from Anaconda is to allow you to write Python snippets in those cells, but they don't run in Excel. They actually get sent to a server.
Yeah.
And of course, there's only one server that they like, Microsoft.
Yeah.
So it is sent to Azure. So this is fine, but it means that your code runs on Microsoft architecture. You pay for that, and all your compute goes on the cloud. The pros and cons of all of this. So that was one thing that happened about a year ago. A little bit before that, technology came out called PyScript. And PyScript is, we've been trying this since the beginning of Python to run Python in the browser. Like, people have tried this, failed, tried it again, failed again, tried again, failed again. So it's not a unique thing, but PyScript tries to run Python in the browser. What makes it unique is the approach, and it leverages something called WebAssembly, which is a virtual machine target, basically, an architecture with machine code that you can compile to. And there's a whole programming compiler framework that you can use to target towards it. And basically anything that is implemented in C or Rust or some other languages can be compiled very easily to WebAssembly. So if you have that as an insight and you look at the Python VM, which is basically a C program, you can sit down and compile the Python VM into WebAssembly, bundle it up, and then run it on WebAssembly in the browser. Now you have to figure out, like, what am I going to do in that code? Like, why would you run it in the browser? But of course, the power is that you can escape to the JavaScript runtime, and through that you can operate on the DOM, and you can do like all kinds of interesting things. You can retrieve information from the DOM, or you can modify it and render new things in the DOM.
Sometimes as a beginner, people get a little lost on some terminology, and I feel like the DOM is one of them, where people are like, well, what does that even mean? Like, what is that, an acronym or whatever? And I don't know if you mind just describing that.
Yeah, of course, yes. So on the topic of communication, it's really hard to explain all these things without visuals. Like, I'm a very visual person.
Yeah, I know.
So if we're talking about this topic, I have a slide up, and it has a picture, and it has words, and there are MicroPython in there, and there's So relaying that structure is a little bit more difficult, but that's a meta topic because we're talking about communication so much. But the DOM is it's an abbreviation for Document Object Model, and that's what browsers use to actually render HTML, which is Hypertext Text Markup Language, I think. Hypertext.
Hypertext Markup.
So a lot of acronyms. No, I have to explain
Exactly.
all the acronyms. So HTML gets interpreted by the browser and then rendered. And what you get back is a document object model. And that is then traversed and converted into pixels that are rendered on your screen.
Yeah.
So this is what you want to access from the Python code that runs on WebAssembly, is you want to somehow get to change things on the screen. You want to render things, words, text, animations, anything you would do in a JavaScript program. Now, why is that important? Is there's a huge amount of people that have background in Python, the millions of programmers, and they hate JavaScript, or they think JavaScript is complicated, or they've never done anything in the browser. So this is why PyScript started, to give Python developers another platform to deliver basically their code in.
Yeah. That's always something I love to talk about, is that beginners and people that are trying to write code often want to show it to others.
Yes.
And share it with others, or have other people use it, and to have to drag them to the office chair and sit next to them, or in their, whatever, and to see something run, as opposed to be able to put something on this universal tool, which is the web, and have a way of distributing it, sharing it, and so forth, is again, like you said, we've been chasing it for a while. So
one of the things we've been changing is running Python in the browser. And I said, like, a lot of people have tried and failed.
Yeah.
But there's one project that actually tried and succeeded dramatically, and that is Jupyter Notebooks.
Yeah, true.
That's a way for writing a story in the browser, where some of the blocks in your story are code, and then the next block is that code executed, and then so on.
Yeah, or instructions and so forth. Yeah.
Yeah, this topic has been covered on your podcast for many, many times, of course.
Yeah.
Because it's a popular way for repeatable research. Like, rather than just read an article, which has pictures in there, you can read this article in the form of a Jupyter Notebook, and you can read the story, and you can actually run it and verify and see if all these statements that they make in the paper are actually true. So this is very popular in research, in science, but it's also picked up by financial institutions. When I was at JP Morgan, for instance, there were hundreds of people in the quantitative development tool area. So these are mathematicians that try to come up with new ways of modeling financial institutions and calculations. They love notebooks because they give you an experimentation platform.
Yeah.
You try things out, it runs. Try things out, run. Try things out, and you wanted this fast iteration. So we have a lot of success in the browser in Jupyter Notebooks, but it's in a different world. Like, it's still coding, right? It's not what business people see and think and are capable of expressing their thoughts in.
Right.
So at the same time that financial industry likes Jupyter Notebooks, and on the extreme, they like VS Code and, of course, like all kinds of distributed programming environments like Spark and all of that for scale. On the other extreme, you have spreadsheets. So you have business people that can express thoughts in formulas. I mean, they're not stupid. I mean, they're not dumb, but they don't have a programming background, right? So this for loops is too hard for them, but yeah, functions they're great at.
Right. Calculations, all that stuff.
Calculations, yes. And spreadsheets are perfect for that. All right, so all these things together. So we have Python and Excel. We have Jupyter Notebooks being great for storytelling. Spreadsheets being great for thinking about a problem as a dependency graph. So you have cell A depending on cell B, which depends on cell D, and so on. So you have a graph, really. I thought of, like, I want to show that you can actually combine all of this together. So I didn't start out to do a startup or become rich of it. Like, it was a niche. I wanted an itch that I had to scratch.
Yeah.
So I wanted to prove that it was possible. I thought, like, Python and Excel, that's for losers. I can do Excel in Python, and it can run in the browser. So I started writing a spreadsheet in the browser using PyScript, and that wasn't easy, I have to admit. The early versions of PyScript were really slow, and they only had Pyodide. I will come back to the difference there, but
sure.
So Pyodide is a bigger VM, and it runs slower, but it can do more. And it really wasn't enough. So I spent a lot of time optimizing my own code to run acceptably. I ended up with something that worked, and I started showing it to people, and they were all like, wow, this is awesome. Like, when can we have it? Now, building something and showing it, that's one. Making it in such a form that people can actually run it without bothering you all the time, there's a big difference. So it's taking me since February. I resigned from JP Morgan, and I focused full-time on PySheets to build it out. So I've been building on it for the last 6 months, roughly, which includes 2 vacations, a dose of COVID. So it's like maybe 5-6 months of real work. And what I have now, I think, is a product that proves the fact that you can build Excel in Python, run it in the browser, and then run all your data science logic also in the browser. So this is all. Initially, I didn't think of that as the theme, but it's sort of turning into the theme. PySheets' theme is local first. So run your code locally in your own browser, run it on top of PyScript. And the final thing I had to solve was, like, where do you store all the information?
Yeah, I was wondering about that.
So that's the final thing. But coming back to Pyodide, I mentioned that earlier. So I mentioned that this effort of running Python in the browser, called PyScript, is compiling a Python VM to WebAssembly and then bundling it up and downloading it and running it. That Python VM is the CPython VM. And this project that manages basically the makefile for this compilation effort to WebAssembly is called PyDite. And as part of PyDite, it also manages a lot of popular Python packages that have native code that people want to use, like NumPy, Pandas. They have a lot of native code, and normally that's a DLL that is compiled for Linux, for Windows, and for different architectures, right?
Yeah.
And nobody has ever compiled them for WebAssembly, because why would you? This is not a target. But since the success of PyDite, which predated PyScript by a couple of years, WebAssembly has now become an official target for all these packages.
Yeah, I've been talking to Brett Cannon off and on about it on the show, which has been really interesting. He's very much involved in that process and making sure the builds are going, and it's been really interesting to listen to, like just across this whole 200 something episodes. I started hearing about WebAssembly 4 years ago and going, why are so many people interested in this thing? And then just to kind of see it bloom has been fascinating. Fix application issues before they become downtime with Sentry error and performance monitoring for Python. Whether you're taming Python's processing power or controlling JavaScript's flow through Node.js, backend infrastructures are as complex as they are valuable. With Sentry, you can trace issues from the front end to the back end, detecting slow and broken code to fix what's broken faster. Within minutes after installing Sentry, software teams are able to trace Python issues back to poor-performing API calls, as well as surface all related code errors. To fix what's broken faster, one engineering leader that used Sentry said, the time to resolve errors went from days to minutes. Installing is easy, and new users get 3 full months of the team plan, free with the code Real Python on sign-up. That's Real Python with no space. Learn more at Sentry.io. Can I take a slight detour? You worked on another project that I feel like is somewhat critical to this project and again, I mentioned it on the show recently, your little toolkit. How did you start that? And then I feel like you're, in a way, a contributor to PyScript through little toolkit.
Yeah. So it started in 1990.
Okay.
When I did my PhD research for the programming language that I mentioned before.
Sure.
So I'll give the name now. It's called Procol.
Procol, okay.
And when I built Procol, I wanted to show people what you could do with it. And of course, you want to build something visual. So I started writing a small toolkit.
Okay.
And at that time, X Windows was the only platform really where you could render things in. And there were like 40 or so drawing primitives. So you basically build abstractions for a button, for a text box, for the layouts and whatever, and you give them names, and then it basically starts rendering by drawing things. Now in the browser, you have a little bit higher abstractions that you can use, but you still need to build, basically tools in the toolkit and the UI toolkit that allow you to build a user interface. And we've done this over the years. Like the current LTK for PyScript is maybe iteration 7 that I've developed personally.
Okay.
In all kinds of different languages and contexts. And
do you bring out your old notes when you work on something like this?
This is basically more on memory. Like it's not that hard to design. You start with layout.
Okay.
So you say, I want to have horizontal layout and vertical layout.
Right.
Although on the web, we've been fighting with tables and declarative layouts, and there's this joke. You say like, okay, you do everything in a table. You do that for a long time. Then you decide to switch to CSS layouts, and then you do this for a month, and then you give up and you go back to table. So layouts are not easy, but so this is what I did for LTK because I wanted to build PySheets, and I needed a toolkit to. So you have to lower your mental mode, right? When you write software, this is why you build abstractions, and this is the art. I think Aho said that. Aho from the compiler book, from the Dragon book. Alfred Aho said, the art of computer science is the creation of abstractions. So that's really the concept that we tried to do. So in order to build something really complex, you have to break it apart in smaller parts. And I did that for PySheets. So I started writing, I need layouts, I need buttons, I need this. And there weren't any for PyScript. because it's a brand new environment. You have to do everything browser-based. You don't have to do things browser. You can also do it in HTML and bring it in.
Yeah, I was thinking that you could do JavaScript libraries and so forth, but then you're working in JavaScript. So
then you're working in JavaScript. And I had this assumption that I wanted to do everything in Python.
Okay.
I wanted to prove that you can do everything in Python. So my JavaScript, which I still escape to for certain things, is minimum.
Okay.
I try to make it like sort of like your native language. Like in Java, you would use CDLLs to escape to native code. But you try to write as much as you can in Java because that's much more portable and much more easy to write. And then you don't write everything in C because then you don't write it in Java. So I did the same thing for Python. So I thought I wanted to write the whole UI in Python. What would it look like? And it ended up being LTK. And I thought this is not unique. This is not special. This is generic. People want this. And so I donated the project back to PyScript.org or .net or whatever they call. So it's now part of the GitHub repo for PyScript as well. So anybody can contribute to it and build things upon it. And that's fun. And it's just actually, later on, I decided you know what? All of PySheet is not that unique. Let's put everything in open source. So now all of PySheets is an open source project. So that's also an interesting discussion we can have. We can talk for another hour on how do you start a startup and make money.
I'm sure, yeah.
So I thought of it's a closed system. There's a really big technical problem with PyScript, with running Python in the browser, is that it has to download over the network.
Yeah.
And then when it gets to the browser, it executes. And the same problem occurs for JavaScript, of course. So all the code is visible.
Right. And people are impatient.
Yeah, for JavaScript, we have minimizers and compressors and whatever. So,
right.
Yeah, re-engineering the code from the artifacts that are sent over the network is much more difficult with that. But for Python, we don't really have good compression tools or minimizers because nobody ever needed them. So nobody has written them.
Because you're mostly running it locally and
Yeah, you always run on a server or locally. And why would you, compress or obfuscate your code? But for PyScript, we really needed that. So I spent probably of the 6 months that I wrote for PySheets, I spent a month writing an obfuscator to protect my investment, right, as a vendor. And at some point I thought wow, this is crazy. This is it's making my life tough because now I had a really complex continuous deployment tool that did all this and it was impossible to debug in production. So I was like, okay, why don't I make everything open source and I don't have to worry about protecting my code.
Yeah.
So there are a couple of motivations for making the code all open source as a product. And there are many examples of this in real life. Elastic Search is an example. MySQL is an example.
Yeah.
The Java ecosystem is an example. That an open source solution, Python is of course also everything is open source. There's still money to be made in this ecosystem. So PySheets is now open source.
Yeah, through several channels we could probably dig into later. Yeah.
Yeah, if anybody here listening that have recommendations for me, let me know how I make money on this. Okay. I'd love to hear.
Yeah. Well, it's interesting because I don't usually have people on to discuss this kind of thing, but I feel like it's a trend. There's a few different projects that are out there that are, it's been a concept I've covered a handful of times, mostly I think the second year I was in, I got really into oh my gosh, these open source contributors are really struggling and they need funding and they need to figure out a way to maintain what they're doing, not completely burn out and just blow up the project. And so, I talked to Tidelift people, I talked to a few different people as different strategies. And then there's been things like Anaconda funding certain projects, which has been kind of interesting.
Yep.
And so in the end, another answer is potentially looking at pitching, maybe I make this to investors and have people help get support there. And then that's a balancing act of, well, now I have people that are quote unquote vested interest in what I'm doing and how I'm going to do it and that relationship. So I feel like that's an interesting discussion to navigate. And I know we don't have a ton of time to dive into it, but at least you can discuss like where you're at with it and starting with it.
So it's everybody wants to be a unicorn. I mean, you want to be valued at, well, I was going to say like 1 billion, but 1 billion is for losers these days, right? You have to be like 10 billion
Okay.
or 100 billion, whatever, right? This is like, the numbers are getting so crazy that like, that is a measure of success if you're valued at this enormous amount of money.
Sure.
But actually that's a curse, because at the moment you get that valuation, their expectations are so dramatically high that
Right.
it's really hard and stressful, and you got to cut corners and you got to race for profitability and meeting your metrics to keep your investors happy. And it's logical. They give you a lot of money and they expect money in return. When I left JP Morgan, I said, like, okay, this is the last time I have a boss. I just want to work for myself from now on. So if you take funding, that means that you have a new boss.
Yeah.
Even though that boss is maybe not breathing in your neck and asking you every week, like, how are we doing?
Yeah.
They still have an expectation at some point, like, why do you spend my money on? And it doesn't make sense. And you have to justify all your activities. So an alternative way of thinking of this is called bootstrapping, where you try to find another way. You live with dry bread for months, and you get one customer paying $100, whatever, $1,000. You start really small, and that just pays the bills to get you a few more customers and then a few more.
Right.
And at some point, you reach the turnaround point where you can actually pay salary to your whole team, and you stay nimble because you're only hiring when you actually make enough money, right? And you're not hiring hundreds of people because you're valued at $100 billion. Right? You have to hire these people. You don't know what they're going to do, but yeah, you have to hire these people.
Right.
So that's a different mindset, a different way of thinking about it. Yeah, there's a different approach. And I always said, like, I want to bootstrap. I don't want to take funding.
Okay.
And I'm also like, I'm very, in Dutch, we're very, not like Americans. They can sell anything and just get money, right? In Europe, you build something first.
Okay.
And then you show it to people, and then that looks really cool. And then they start paying for it.
Yeah. It's not necessarily just a vaporware demonstration kind of thing. Yeah.
So that was my approach. I don't want to show it to anybody unless I have something to show.
Yeah. Okay.
So my approach has been build it first. And I'm right now at the point where I'm actually ready to do presentations. So by the time you listen to this, this happened in the past. But so this was recorded in it's September 13.
Yep.
So this is sort of mid-September, and by that point in time, I was done. People can download it, they run it, and it works. And I'm comfortable giving it to customers in financial institutions. And I'm talking to one in mid-September to actually deploy it in their organization. A lot of people, they ask me, like, so is this an alternative to Excel? I say, no. I'm not trying to replace Excel. Oh, Google Sheets then. No, I'm not trying to replace Google Sheets. So what are you trying to replace? So what I'm trying to replace is Jupyter Notebooks. And I think they've been around for 20 years, and it's time for a revolutionary idea to rethink what Jupyter Notebooks should look like.
Okay.
And I think they should have a spreadsheet UI. And this comes back to the whole beginning, to the communication part, empathy,
right?
Business teams, engineers not talking to each other. I want to build an environment where both of these teams, both of these different worlds can interact with each other. And Excel is not that, even with Excel in Python, or Python in Excel. Jupyter Notebooks are not that, but PySheets actually is. And this is my strong belief. This is my passion. I think that it's a technology, it's a tool, and we can focus on, it's using PyScript WebAssembly, it runs in the browser, and it has local storage in IndexedDB. All of these things are technical values. They are meaningless. Like, somebody in the business don't care.
Right.
All they care about is they want insights. They want to have decision-making process that is effective. And they need data.
And they want their people on the team to be able to recognize what this tool is and like, oh, this is
Exactly.
a spreadsheet. Okay, I know how to use those, like
Yes.
columns
and they
and
look
rows.
at it, and it looks familiar, and it
Okay.
looks friendly. It doesn't look fake, right? Because they see it, and that was my thinking. So it's an easier delivery mechanism. The best thing we can do today is dashboards. So we have a Tableau dashboard, and we have data pipelines that generate all these pictures, and they get sent to the business. But it's a one way, right? There's no feedback loop, and I wanted to make a way to empower anybody on the side of PySheets, whether you're business, sales, or logistics, or management, or you're a data scientist and you're an engineer. We can all interact in the same environment. So that's a dream that I have.
Yeah.
Very interested to work with other people to execute on that dream. And that's what I've been doing with one financial customer. Like I said in the beginning, also, I have experience with working at technical companies like Uber and IBM and Google, but also at half of my career has been in financial institutions. And I'm very sensitive to the demands that the financial institution has. Like, these are words that we normally never hear when you write, I don't know, software at a place like Uber, is regulatory constraints.
Yes. I know that stuff. Yeah. Yeah.
Things like when somebody says buy side and sell side, there's so much meaning behind these two words. That means that if you work in the buy side, that means that you buy things. You cannot tell anybody on the sell side what you're buying and selling. It has to be very anonymous.
Has to be
and
separated.
There's all these separations in the organizations that won't even let them talk to each other. You're not allowed to visit the same floor that these other people work on. And
right.
So all these things impact how you deliver software in these organizations. So there's a lot of entitlements, a lot of like auditory trails. Like an audit comes in, somebody from the SEC comes in, and they say like, okay, show me the system. And you show the system, and it says, this number says 12 million. Why is it 12 million? And you have to explain that number.
You have to have that story. Yeah.
And you have to show the story behind it. You have to show all the code. So what is the code that generated this? Who are all the people that edited this code? And you have to show the whole history of this number. And then they go to a different desk and it says 11 million. And they say, why does this one say 12 and this one 11? And if you cannot explain that, then you lose.
Right.
And these are extremely important sort of side effects. And they're part of a culture, but they're also different demands, right? Different requirements, and they drive how people use software.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It's about a topic you hear bantered about often when discussing performance in Python, and has especially come into focus with this year's release of Python 3.13. The course is titled Understanding Python's Global Interpreter Lock, or GIL. It's based upon a tutorial by Abhinav Ajitsarya, and in the video course, Christopher Trudeau takes you through understanding the concepts of concurrency and processes, the differences of threading and multitasking, and what are race conditions and how Python solves them, how the GIL works, and what have been attempts to remove it in the past. I think it's a worthy investment of your time to understand how the GIL affects Python performance and how you can mitigate that impact on your code. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. Can I briefly ask you about IndexedDB? I'm not familiar with that.
Yep.
And was wondering kind of like what it is and then how you're using it.
Yeah, so a database is basically you store data. You store data in a format that it makes it easily retrievable.
Yeah.
Now, depending on your usage scenarios, different structures make sense. A very popular one is relational databases.
Right.
They've been around since the 50s, and they're very popular because they show relationships between entities. And you usually have a key, and you have foreign keys, but you can do indexing, and then you can very quickly find all the people that live in New York.
Right.
Just select people from cities where and equal, right? And if you have an index, then it's really fast. Now, a graph database, for instance, is different, where the data is structured by connections between objects. So you have one object has a pointer to another object, has a pointer to another object, and the data has a form of a graph. Now, if you want to find objects, you have to basically walk the graph.
Okay.
And your query becomes a graph query. So that is another way of thinking about it. And then the third model is something like a key value store, where you have basically a really big hash table, and the keys are just keys, and the values are objects. If you want to find things, then you go to the key value store. And so some of these databases, they are very popular since the beginning, and they're hosted by cloud vendors. So one of them is Firebase, for instance, which is an offering from Google, and it's a key value store. So for storing sheets, that's very unique. It's a perfect match. So when I started with PySheets, Firebase, very logical. It's basically a hash table. And the key is the identity, the key for the sheet, and then the document is just a JSON file. And then I stored that there, and then I started talking to my first financial customers, and they said, well, we want to have an on-prem solution, so it's impossible to store the sheets at Google.
Right?
Regulatory constraints, compliance, right? Never, ever. Okay, so I need a local database. Okay, what database would work for you? MongoDB. Now, MongoDB has a different API, so how do you do that? So I started actually manually transferring the code, and I was like, oh man, I'm an idiot, stupid. We have an AI for this. So I launched SourceGraph Cody, which is a plugin for VS Code, and I asked Cody, here's my implementation of PySheets, and it currently goes to Firebase. Can you rewrite it so it goes to Mongo? And an hour later, it did it. It worked. So then I had MongoDB working, and I also switched to DigitalOcean because it was a little bit more flexible than App Engine and closer to my mental model of local development.
Yeah.
And then I had to buy a license for MongoDB. I thought, that's annoying. Aren't there any free databases? So I ended up with MySQL, but MySQL doesn't really solve that as well. But AI wrote it for me in another hour. And then I said, SQLite, because that's built into Python. And it's not really a database, but it's a local file.
Right.
This is all I need for PySheets. I'm not going to store terabytes. So makes sense, SQLite. And then I used SQLite, but I still had a local file. And I thought Then somebody told me, why didn't you use IndexedDB? I said, IndexedDB, what is that? So I did a query. Mm-hmm. And it's basically like if you have any applications written in the browser, you can store things in the browser. It's called local storage. Mm. So in JavaScript and also in Python, you can say window.navigator.local storage. And it's also a key value store. So you can say key becomes object. And then it stores it. And that's what IndexedDB is as well. It's more scalable. So it has less restrictions than the key value store local store has. And you can build more interesting schemas. But I'm not using that power that much. I'm more interested in the size. So IndexedDB is a browser that runs in the browser. It's part of Chrome. It's part of Brave or Edge or Safari, or it runs in the address space of the browser. And it stores it in the browser itself. So it's encrypted, stored on the file system where next to the browser. And that, in the end, was my final target. And it took me a day from going from one implementation through 5 iterations to come to an IndexedDB solution. And that is fully local in the browser.
Nice.
So that's another theme that we could talk about for another podcast is to use AI to get more effective at your coding, of course.
Yeah.
I thought so I have to build AI in PySheets as well, because this is, first of all, otherwise nobody will buy it. And you will never get investors to invest in it.
As a modern tool, right? Yeah.
It has to have AI. But it's actually really practical, because I started using PySheets myself to build examples. And I knew a little bit of pandas, but I actually met Wes McKinney before he was Wes McKinney. Before he was peddling pandas when it wasn't pandas yet. It was on PyData in New York. So since then, I've been following pandas, and I've written a little bit of code, but I didn't know all the APIs. So I was trying to build examples, and it was hard. I had to go to Stack Overflow and come back and say, well, come on, I need AIs for this. So I hooked up OpenAI to basically look at your spreadsheet, look at the data frames that you generate, and give you Python code to do the visualizations, to build matplotlib plots and things like that.
Yeah.
All of that, I knew the concepts. I knew it was possible, but I didn't know I can express this. I can write the prompt, right? I can say, take the data in this cell A1 through B10, whatever, and turn it into a data frame. I can say that, but I don't know what the code is. And when I see the code, it makes a lot of sense. Oh, yeah, that makes sense. Oh, that looks weird. And then, are you sure about that? Oh, no, excuse me. Yeah, I was wrong. Yeah, and then it fixes it. So for the data scientists and maybe for business people, salespeople that want to empower themselves to do this kind of analysis, this data flow, writing a data flow, I think the AI will be an enabling and empowering tool to get them to that spot. The same way that it accelerated my experimentation from 5 different database solutions.
Yeah.
The same way, the same struggle people will have with their data analysis. Yeah, it's all coming together now. I'm in a really happy spot where PySheets, it's really fast. That too. I said I'm not replacing Google Sheets, but Google Sheets was my inspiration.
Okay.
I wanted to be as fast as Google Sheet. And it's hard to scale to really large sheets. So that is still a different domain. There are people offering really fast spreadsheets in the browser that can scale to millions of rows. And they use what's called windowing, where they only render a couple of the rows. And they spend a lot of effort into optimizing that. That's not my niche. The niche I'm trying to find is experimentation and iteration and discovery of information.
The notebook part.
Finding out what the algorithm looks like, and do that not just by yourself, but together with the person that owns the business, and have that quick turnaround time. So sharing is more important. Common language is more important. And AI will help with that because you can explore things a lot faster.
You've hinted on a few different things that someone would see in quote unquote a sheet. They would see the data itself and the ability to turn it into a data frame, and then the ability to create charts and graphs, and they can see the code off to the side of it. This is something that you have a try button where somebody can open up a browser and get a chance to sort of play with it a little bit themselves without going through the process of installing it completely. But what I'm wondering about is kind of that notebook idea, this experiment idea. Is this all going to be in a singular sheet, or are there pages or other, I'm trying to remember the term for it. They call them like a workbook, right? And then there's sheets within a workbook. Is it a similar concept to that?
So I think eventually, yes.
Okay.
At the moment, I wanted to focus on the core problem, the core functionality.
Okay.
So when I started off writing PySheets, it was actually twice as powerful, twice as complex. And this is the hardest thing ever, is if you're a seasoned engineer, you know this, you've seen this yourself. The hardest thing is not to add features, is to take away. And so after 3 months or so, I started taking away and starting to reduce, because you want to make the tool as simple as possible so people get it.
Yeah.
And if they want new features, then they will add them themselves because it's open source. You can just add your own features if you want to. So that's, at the moment, it doesn't have workbooks, but that is a feature that is naturally possible. The data is stored as a JSON document.
Okay.
And the JSON document says cell A1 has this value, cell A2 has this value, A3 has this value, and the preview for cell E4 is this, and so on. And you can walk that, and you can imagine that you have one layer higher that says notebook, whatever, and then the cells are this, and then the second notebook. And so we can build that structure very easily and make it in the UI so that you have multiple tabs. That's not really the biggest problem. I think the biggest problem, I don't know, it's things like, how does Google do their real-time editing of the sheets?
Yeah, okay.
Right?
Collaboration and such.
That is not trivial. That is not a trivial problem. I've worked on this professionally, and I have it working in PySheets. It's not currently a feature that I removed, but that is not a trivial thing, is to edit things in real time and get really fast reaction and get like eventual consistency, right? That's also a hard part. Like if I type something in and you type something in and we do it on the same cell at the same time, who wins?
Right. Yeah, race condition of sorts.
So those kinds of things, race conditions. If you select the whole sheet and you do delete and I just write something like, so all these things is at some point you want versioning of the sheet. Google Sheet never had that programmers, we Python programmers, almost all of us know about Git. That's why we store our code or equivalent versioning systems at work. But people work on this repository at the same time. You work on file A, I work on file B, and at some point we have to merge our work.
Right.
Because we can't really force the other person not to work until we're ready. You can't lock the data. That's one approach that was actually popular in the 90s, is you could freeze, so you could lock certain files. That means that other people couldn't edit that file until you're done with it.
Yeah.
And that's because at that point in time, we couldn't solve the merge problem yet. Now we know, like we can just do structural analysis of the files and we can see, we can show you, right? And you edited this and you edited that. That's no problem. We just merge it. So at some point, you need that for sheets as well, especially in the financial domain. I mentioned that audit trail. The auditor says, like, who edited all this code? Like, we have to show. People want to edit the sheet in real time, but the multiple people together, we have to remember who touched what. So for all of that is, thinking about the data structure of your code, of the sheets. I spent a lot of time like figuring out like what the data structure looks like. And again, this is inspired by working on these things in the past. So at Bank of America, for instance, we introduced a system called Quartz, which replaced existing trading platform solutions. And we had a database which didn't edit things. So if you want to update an object, normally what you do is you check out the object, you get all the values, and then you change the value and you write it back. Right? You have a write or put operation. This database didn't have that. What it did is it stored the edits. So you had an object, and then you say, like, I change like this field from this to that, and you write out the edit. And again, this is for allowing you to reason about the changes in the past. And once you have that built into the database, this approach of, like, you don't know what the object looks like until you've seen all the edits. So editing in parallel becomes a possibility.
Okay.
But also merging. And a very interesting thing is you can do time travel. You can go back in time to the database to a certain time and say, like, what did the data look like at that point in time? And that's very interesting for financial institutions for doing backtesting. So you want to run your code against the data from yesterday, but also run yesterday's code against today's data, things like that.
Wow.
So if you have databases that can do that for both the code and the data, then you're very powerful. So all of those things have inspired and influenced the implementation of PySheets.
Yeah.
And if people want to know about this, you can go to GitHub and PySheets/PySheets, and you can just read it. You can read the code and see all this.
Yeah, we'll make sure to include, you have a really nice landing page at PySheets.app that lets people kind of get an idea of what's happening with it, the features. You have a try button and install button, and people can kind of learn what's happening there. If someone was interested, is this a situation where you're looking for people to help contribute on the project?
Yeah, it's like I open sourced it. The same reason that Jupyter Notebooks is open sourced is to make it available to a larger domain than just my intended commercial customers, right? I think it's a perfect tool for teaching, for college professors to do their educational parts in it, to have explanations about certain concepts and use it as a more interesting Jupyter Notebook, as an alternative to Jupyter Notebooks. So git clone the repository, fork it, see if you can use it in your environment. If there's anything missing, add it and send a PR. And let's build an ideal experimentation environment that fulfills the needs of these kinds of audiences. So that would be awesome if people do that.
Cool.
And the second thing is explore in your commercial environment, let's try it out. Does this give you a better platform to imagine what the model looks like, what your solution looks like, your algorithm looks like? Can you find the data sources more easily? Is this more malleable? Is this more explanatory to the business than a dashboard? And the nice thing about PySheets is that I mentioned it a couple times. It's written in Python. It runs in PyScript, but it runs in the same address space as your cell functions as well. So what you can do is you can write a module, you can publish it on PyPy, and then you can import it from PySheets, and you can actually change the experience. So I mentioned before, it's like sharing your sheet with other people. I intentionally removed that because I imagined that that would be different in all kinds of organizations. Like some people will use, Google Drive. Other people want to use Dropbox. And so I thought, like, I can write that, but it would be much easier to write it in a package, publish it on PyPy, and then have that, import that in your sheet, and then it morphs into the experience, and it changes the UI. It can add buttons. It can add menu items. So imagine you write a sheet that changes the experience in Excel or Google Sheets. What could you do?
The extensibility, which is not usually you can't touch on any of it. Yeah.
Normally, this is a closed system. You cannot do that. And I designed it in a way that you can. So it would be really, it would be awesome if people did that and showed me, because that proved to me and that would make me feel good. So I'd love to see that. So for both commercial applications, educational examples, but also how people use it as a platform and not just as a tool. I think that's always a good software system is a platform. It's not a closed system.
Yeah.
Because I cannot predict what you want. I've learned that over 30 years. My empathy is still not there that I can imagine what people need, right? Market fit. Yeah. This is like, we talked about like investors, and so market fit is another magical word that you have. Like, what's your market fit?
Yeah.
For PySheets, I will say, like, it's a platform. People fit their own market in it.
Yeah.
It's not for me to find the market fit. But of course, that's maybe they will not accept that easily. So I will see.
Yeah. So I have these questions that I like to ask everybody that come on the show. And the first one is, what's something you're excited about that's happening in the world of Python right now?
So one of the things I'm very excited in is PyScript. Like, we talked about it for quite a while now.
Yeah.
But I didn't mention is actually, we haven't mentioned it yet. I mentioned the word PyDite, which is the C Python implementation that is compiled into WebAssembly. But there's another Python VM that is supported by the PyScript team that's called MicroPython. And MicroPython is a really interesting Python VM. It's a really tiny Python VM.
Yeah.
So C Python, I don't know, it's 10 megabytes or something like that. Now, it doesn't sound like much in these days where your disk can get 2 terabytes.
Right.
But for delivering to the browser, it has to download these 10 megabytes. Doesn't sound like much, right? Well, MicroPython is actually 240K, and compressed, it's 120K.
Wow, yeah.
So that is less than any average JPEG that you download. Probably the logo for your podcast is bigger than 120K.
Could be, yeah.
So the fun thing about MicroPython is it's ideal. It's built for embedded devices. That's how it started. Raspberry Pico, embedded the really small machines.
Yeah, definitely. Yeah.
There you have no memory. Everything has to fit into, 128K. And the fun thing is that I used to work on those things in the past. So this is sort of reviving this. My work environment is called Visual Age Micro Edition, and that's the IBM's J9 VM for embedded devices. And our entire Java VM at the time fit in 1 megabyte, including all the class libraries and your application. So I have a lot of affinity and recognition for small VMs. So I love MicroPython, and PyScript is giving it another platform to shine on. So LTK, for instance, but also PySheets, the UI runs entirely in MicroPython. So it comes up in 100 milliseconds.
Yeah.
So if you try this now, you go to pysheets.app. The first time it might take a second because your cache is still cold.
Right.
But if you do a refresh, what you want to do is like refresh it 3 or 4 times and see how fast it is. In that time that it comes up, It launches, it basically downloads your artifacts from the cache.
Mm-hmm.
It downloads the WebAssembly package for MicroPython, and it brings up the MicroPython VM. It installs its class library, and then it loads my Python code and runs my Python code, and my Python code runs, and it talks to the DOM, like the document object model, like we talked about in the beginning.
Yeah.
Renders things in the UI, and that whole process is 100 milliseconds.
Yeah, it's impressive.
So that is really impressive.
Yeah, that was a neat change. I'm trying to think of when that happened, like maybe last year sometime. They had made it, and it was like, oh, okay. Because I talked to some other people that make other tools about, they're like, but Python's so big, it'll never, and so forth. And so this really kind of steps over that barrier. And especially if you can do something like the graphical user interface library kind of stuff with it, a lot of ideas open up very quickly.
I remember like it reached Hacker News front page in May or something.
Okay.
And there were quite a few reactions, like you said, like, I tried out PyScript last year, but it's so slow, I can like do anything. But this is fast, man. It's just like unbelievable.
Right.
So that is really a savior for PyScript, I think.
Yeah.
MicroPython. And you can do both VMs.
Definitely will expand the use cases.
Yep.
Yeah.
So PySheet is running two Python VMs. So it comes up with MicroPython, and in the background it starts a web worker. And that one runs Pyodite, so the whole shebang. So if I do anything pandas, if I do anything numpy and matplotlib, it runs in that worker on Pyodite, and they talk to each other, and the MicroPython VM runs everything in the browser.
Yeah, cool.
So this is, coming back to distributed programming. We don't have shared memory, but I do a lot of message passing between the two, and it all works. So
that's cool.
So MicroPython is really cool.
Yeah, very much so. What's something that you want to learn next? Again, this doesn't have to be programming.
What do I want to learn next? My daughter is really into 3D printing.
Okay.
So she likes to play board games, but she has a large collection. And the problem with board games, they have a lot of cards and little figures and whatever.
Yeah.
And it gets a big mess in the box.
Yeah.
Right? So she has made incredible models in 3D for little trays and things, and they all fit into each other.
Oh, okay.
And so you open the box and everything is like neatly organized, and you take out the little parts, and I thought like, I want to learn 3D printing as well. Like
still trying to find my favorite library to build my models in, and there's one that's written in Python, and thinking about trying to maybe get somebody from the team in. It's called FreeCAD.
Yeah,
it's not the prettiest library, but it has some really interesting functionality that I think is pretty cool. And
so 3D printing would be if I ever retire, that would be something I go do.
Yeah, fun. We mentioned a few ways that people can definitely check out PySheets, and we talked about LTK and then in your book. But in general, like if people want to follow the work that you do online, what's a good way for them to do that?
Yep. So the best starting point is chrislaffra.com. So one word, Chris, no space, no dot, Laffra.com. And there's a lot of links on my page to the projects that I work on. There's a link to on the YouTube videos that were recorded with podcasts, but also presentations that I did.
Yeah.
And it gives you a good sample of the kind of things that I do. I'm very active on LinkedIn, so I'd love to meet you there and grow my network and learn from you all.
Cool. Chris, thanks so much for coming on the show and sharing all this stuff with us.
You too, Chris. It was a pleasure. I enjoyed it. And nobody on the podcast can see this, but I can see actually Chris's room there. And he mentioned he was a musician. And I see 1, 2, 3, 4, 5, 6, 7, 8 guitars. So he has a nice collection there. I'm very jealous.
Well, yeah, you can come by and jam anytime if you're in the middle of the U.S. So
yes, you're in Colorado, right?
Yeah, that's right.
Yeah, I should come there.
Okay. All right. Well, thanks again.
Okay, Chris, it was nice meeting you. Bye.
And don't forget, installing Sentry is easy, and new users get 3 full months of the team plan, free with the code RealPython on sign up. I want to thank Chris Laffra for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player, and if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.